Hello, everyone, and welcome to today's webinar on the future of generative AI on content management and digital experiences. I'm Mike Vertel, CEO here at CrafterCMS, and with me today is Russ Danner, our VP of Products. Thank you for joining us today as we dive into this super exciting topic. Our agenda today will start with an overview of generative AI with a focus on the current state of the industry, along with the trends and best practices. Then I'll highlight some key GenAI use cases for all stakeholders, including content authors and editors, software developers, and the end users of your CMS-powered sites and apps. I'll then hand it over to Russ, who will talk about a system architecture for generative AI applications applicable to both content managers and for those building digital experiences. And then he'll dive into some real-world examples and demos of a variety of use cases that you can utilize today, including AI assistants for creating content, chatbots to improve the productivity of content authors, chatbots to add to your sites to increase the engagement of your site visitors, and even an AI agent for building content and site experiences. Very compelling stuff, and I'm sure it will provide you a glimpse of the future of GenAI's impact in this area. We will leave time at the end to answer all your questions, so please click the Q&A button to send us any questions throughout the presentation, and we will answer them at the end. So let's get started. Over the past few years, we've witnessed a major shift in how GenAI is reshaping virtually every industry. According to this poll from McKinsey, the adoption of generative AI in particular has surged from about 30% to over 60% in just the past year. This remarkable growth underscores GenAI's potential to revolutionize how we create and deliver content-rich experiences to all of our audiences, whether it's customers, partners, employees, and so forth. The same survey looked at key GenAI use cases by functional area. The data shows that marketing and sales, product service design, and IT are the top three functional areas that are currently adopting generative AI. And I think that covers about 99% of our audience here today, so highly relevant. And when you drill in further to the data, you find that the most popular use cases throughout these functional areas are, number one, faster content creation, number two, accelerated prototyping and development of software, and number three, real-time customer engagement. So from improving productivity to fueling product innovation to boosting engagement, generative AI is proving to be an essential pillar for companies aiming to compete in a rapidly evolving market. So let's discuss the key generative AI systems, approaches, and best practices that are utilized today. The foundational component of GenAI are large language models. They're at the core. Industry examples include ChatGPT from OpenAI, Google's Gemini, Claude from Anthropic, which has a major investment from AWS, so that's their play, and Llama from Meta, which is an open source alternative that allows enterprises to deploy and host on their own private infrastructure. These LLMs are all trained on vast amounts of content and data, and they rely on patterns within this training data to perform a variety of tasks such as content and code generation, brainstorming ideas, summarization, language translation, among many other use cases. Their versatility makes them invaluable for multiple domains, from customer service to web content creation to software development. However, challenges remain around issues such as bias and accuracy due to hallucinations. If we look at the same industry survey from McKinsey that I referenced before, enterprises that are adopting generative AI identify inaccuracy as the number one risk. So while the benefits of AI are significant, these other risk areas must be addressed to ensure AI initiatives remain productive and useful. So how do we fix this? Let's discuss some technical approaches and best practices for using LLMs and maximizing their usefulness and improving their accuracy. And let's start with prompt engineering. Prompt engineering is the practice of carefully designing the inputs or the prompts that direct an LLM's model's output. Rather than simply typing in a request or a question, Prompt engineering involves crafting specific, structured instructions to guide LLMs toward producing more accurate, relevant, and high-quality results. At its heart, prompt engineering revolves around understanding how an AI models interpret language. By refining the phrasing, the context, and the structure of a request, you can effectively teach a model what information to focus on and how to respond. Why does this matter? It starts with efficiency and accuracy. Well-crafted prompts reduce ambiguity, lowering the chance of irrelevant or erroneous responses. It allows customization. Different use cases require different tones, formats, levels of detail. Prompt engineering allows teams to tailor the AI outputs to suit specific business needs, whether it's generating marketing copy, summarizing reports, or assisting with software coding. And then there's consistency and quality control. By standardizing on your prompts throughout your organization, you can maintain a more consistent style and voice, ensuring content quality over time. How to implement prompt engineering? Some of the common techniques start with contextual framing, providing the AI with background information or examples to better understand and tailor response to your requests. Role assignment, asking the AI to act as a particular kind of expert. For example, you are now a marketing strategist, which can help guide the model's reasoning. Constraint-based prompting is where you can specify certain formats or limitations. For example, provide a 100-word summary or answer only with bullet points. And then there's iterative refinement, where you're continually adjusting and retesting prompts to improve the AI performance as requirements evolve. Best practices for prompt engineering starts with being specific. The more precise you are, the clearer and more on target the output will be. Providing examples. This is known as one shot or few shot. One shot if you're providing one example, few shot if you're providing multiple examples. It shows the AI what a good answer looks like. You want to anticipate and test edge cases. Plan for those scenarios where the model might misinterpret instructions and correct for them in your prompts. You still have to establish quality checks. Even expertly engineered prompts, human review is still essential to catch any inaccuracies or inconsistencies. And then I want to introduce the concept of prompt management. I talked earlier about how consistency is key across your organization. So you want to start building reusable templates. You want to start using version control, maybe A/B testing of your prompts. In other words, you want to content manage your prompts. A CMS should be able to handle your prompts too. So these are some of the best practices for prompt engineering today. Another technique for improving accuracy of LLMs is fine-tuning of public LLM models, for example. Fine-tuning is the process of taking a pre-trained LLM, like ChatGPT or others, and adapting it to perform a specific task or operate within a particular domain. Fine-tuning focuses on refining this knowledge using a smaller domain-specific data set. And during fine-tuning, you're updating a subset of the model's parameters so that it can better align with your organization's use cases, whether that's specialized content creation, customer support, automation, or sentiment analysis, etc. Some key considerations for fine-tuning starts with data quality, as the final output is only as good as your training data. So ensuring accurate, high quality, and diverse examples is critical to a successful fine-tuning project. Overfitting is a risk. If the fine-tuning data set is too narrow, the model will become overly specialized and struggle with more general queries or contexts. And maintenance and updates needs to be considered. Regularly updating the model with fresh data, keeping it aligned with evolving requirements and your product lines, compliance and regulations, and so forth is another key consideration. So that's fine-tuning. Another best practice, which is more of an architectural approach, is called Retrieval Augmented Generation, or RAG for short. RAG is an approach that combines an LLM's generative capabilities with one or more external knowledge sources. The goal is to enhance the accuracy and relevance of AI-generated content by grounding it in real-world, up-to-date, and domain-specific content and data. As shown in this flow diagram, there's a few different steps. It starts with the retrieval step, where the RAG system first takes your prompt and query, and it queries a structured or unstructured knowledge base, which could be a vector database or external APIs or a combination. You then have an augmentation step, which is where the most relevant results from this retrieval step are then fed into the LLM as contextual input, and it guides the generation process. And then you have the generation step, which is where the LLM then uses the enhanced prompt and the query to craft a more accurate, up-to-date, and domain-specific response. Why would you want to use RAG? It starts with improving accuracy by incorporating current authoritative information at the time of a query. RAG reduces the risk of AI hallucinations. It addresses domain relevance, similar to fine-tuning, but more cost-effectively. Organizations with specialized or proprietary data, such as your technical manuals, policy documents, product catalogs, and so forth, can keep an LLM's responses highly relevant and tailored to your use case, to your organization. And it is more cost efficient. It can help keep models smaller and less expensive by offloading knowledge storage to this retriever process rather than baking it all into a model parameters. Example use cases starts with customer support, equipping chatbots with real-time access to technical docs, FAQs, product guides, and so forth. Content creation, where you can pull in your internal source documentation, your data, content, references to ensure that outputs are factually correct. Personalized recommendations, providing an LLM with up-to-date customer data, like purchase history or browsing behavior, can tailor product suggestions. And knowledge-based apps, for example, allowing you to build better intranets or customer portals or technical support experiences that empower your employees or customers or developers to quickly find the right information. And compliance applications, where you query the latest policy guidelines or regulations to enhance AI's output. Now let's move to probably the fastest growing approach to generative AI, which is the use of AI agents. Agents are autonomous software programs that execute tasks, make decisions, and interact with systems on behalf of a user or an organization. It's best summarized by this quote from Google's recent white paper on agents. They achieve a goal by observing the world and acting upon it using tools that it has at its disposal. Unlike standalone LLMs or chatbots, agents operate with a higher degree of independence. They dynamically interpret goals, they plan how to achieve them, and they adapt to changes in the environment. A key here is that an agent has agency. In other words, it's not driven by a predetermined workflow, but instead it decides for itself the steps it takes to achieve an objective. An AI agent is goal-oriented. Given a goal or a set of goals, for example, generate a content strategy for this new product launch. It will break down those goals into actionable steps, self-assign itself to tasks, and execute them without requiring continual human oversight. An agent augments LLM's core capabilities by turning passive content generation engines into more proactive, intelligent systems. They can reason, interact, and execute commands on behalf of your content authors or content strategists, software developers, IT operations, and so forth. And they continually learn. Over time, AI agents can learn from new data and feedback, improving their accuracy and efficiency. Some of the key considerations for agents starts with API-first platforms. They play a crucial role in enabling agents to integrate across various services and data sources. For example, a headless CMS. By prioritizing well-documented and robust APIs, headless platforms make it simpler for agents to access the functionality and the content they need. Also, the oversight and control. So while the automation drives efficiency, human governance is still essential to prevent errors, security issues, or unintended consequences. Reasoning processes behind agents can be opaque, and it makes it difficult to audit or understand the decision making. So the output quality checks are important. And compliance. Agents, as they take on more responsibility, you still need to ensure they comply with your privacy standards, any regulations, and any other company guidelines. Okay, so now let's move to some use cases related to content management and digital experience development, where you can put these generative AI systems and techniques and best practices to work. Starting with the authors or the CMS users, a variety of use cases here, starting with content generation of all types, not just text and marketing copy, but images and video. You can optimize content for different audiences or channels. Automatic tagging and metadata creation and categorization of content, scheduling of content, allowing AIs to determine the best time to publish certain content, using LLMs to translate to different languages and localize experiences to different regions, to create different variants of content, for example, for A/B testing, transforming asset types is another example, and analyzing user-generated content for moderation or for sentiment analysis as some examples. From a developer perspective, several use cases as well of generative AI. Starts with software code generation and generating templates for sites and apps. This can extend to even landing pages and microsites. AIs can help with code reviews, generation of test cases, and prototyping of back-end integrations. And then we have the end user experience and different use cases there, starting with chatbot assistance, customer service, and enhanced search. Think about what Google has done with their AI overviews. You can add more advanced search to your end user experience, turning it from just simple search queries to more of a conversation. Personalizing experiences can be helped with LLMs. And then I'd say some agent type use cases that are multi-step. For example, onboarding of customers or employees, product selection on your site for guided discovery and upselling and cross-selling different products, automated A/B testing across different variants and different audiences, and lead qualification and routing, another end user experience. So these are just some examples, and by deploying these AI-powered capabilities within your CMS-powered sites and apps, you'll be able to deliver next-generation digital experiences at scale with much higher levels of speed and productivity. Now, I will hand it over to Russ, who will demonstrate how to implement some of these key strategies, such as LLMs that are enhanced with prompt engineering and RAG, to create a few real-world use cases, such as content creation assistance, chatbots, and agents to add to your websites and apps. Russ, over to you.
Thanks, Mike. That was a great foundation for us. Now, what I'd like to do is take a look at how we can put some of these ideas to work. And I want to start by looking at a high level architecture for AI apps. Our architecture is going to start with three distinct layered spaces. At the base is a layer for data and services. In this space, we'll find core AI capabilities, services, and data stores such as LLMs, vector stores, stable diffusion services, speech to text and text to speech services, and vision and recognition systems. As Mike mentioned, LLMs, or large language models, are a key service that can process, interpret, and generate human language. Vector stores are specialized databases for storing and retrieving embeddings. Embeddings are data that is vectorized into multidimensional space in a way that represents relationships between the data points. Stable diffusion is a specialized type of generative AI model that can be used to generate images and video. And we also have other deep learning based services related to vision and speech. Just to anchor these services with products and platforms in the space, here are a few popular platforms for each category. Now, the next level above the data and services layer is the orchestration layer. In this space, we'll find frameworks for coordinating and orchestrating AI workloads with a couple of objectives in mind. The first objective is to abstract interactions with the services and stores in the layer below so that we can more easily plug and play with different platforms and vendors without needing to rebuild our workloads or our apps and agents that rely on them. Another objective is to provide pluggable templates for common boilerplate usage patterns, like the RAG pattern in architecture that Mike talked about. And the third objective is to provide a place for and support for our domain-specific adaptations. Here are some popular orchestration frameworks that we see today. LangChain, for those working in Python. LangChain for J is a Java-based implementation of the same framework. We also have Spring AI, which is also a Java-based orchestration framework that is woven neatly into the Spring stack that Crafter is based on. And you have AutoChain, which is another Python-based framework that sort of competes with LangChain. And much like our previous slide, these are just a few of the emerging frameworks out there. Now, building above the orchestration layer is our AI apps layer. It's through this space that our end users will interact with our AI apps, AI assistants, and guide and monitor AI agents. Also in this layer, in the context of content management, is where we're going to see a stark distinction between content authoring and content delivery focus. Some examples on the authoring side, just to name a few, are GenAI capabilities built directly into Crafter Studio. We also have a plugin framework and a marketplace where you can find AI-enabled capabilities. And here you'll also find interfaces to task AI agents with authoring use cases. On the delivery side, just a few examples, we can find AI chatbot assistance, AI-backed search and personalization, and as Mike mentioned, you also have agents focused on supporting larger customer journey workflows as well. Now in this slide, highlighted by the red, we can see that CrafterCMS can help us in each of these layers. That said, the key layer where CrafterCMS can provide the most support is in the orchestration layer. We build on top of general orchestration frameworks like Spring AI that give you pluggability in the data layer, as well as boilerplate templates for AI workloads, with additional content management specific and CrafterCMS specific capabilities and SDKs. These also reach up into the app tier with SDKs for common UI and other types of interaction modalities that you can leverage in your own authoring plugins or your content delivery experiences. And in the data and services tier, CrafterCMS is agnostic. However, it's worth noting that we do provide out-of-the-box integration with OpenSearch, which in addition to its typical role as a search index, can also serve as a vector store for embeddings that can be leveraged by your AI workloads. So now we have a general architecture for our AI apps. And what I'd like to do is look at some specific examples. So let's start with some basic GenAI prompt engineering in the context of content authoring within Crafter Studio, where we can leverage the LLM to generate copy and images. Let's look at the components of this solution within our architecture, and then we'll go see that in action. So let's start with copy generation. Here we can see that Crafter Studio will provide us with a user interface that we can use to generate copy by interacting with the LLM. The UI will work through the orchestration layer to connect to the LLM, which in this case will be OpenAI. And here we can see that the design for generating images is very similar to that of the design we would use for generating copy, but instead of using the OpenAI LLM for generating copy, we're going to use image generation services, specifically OpenAI's DALL-E, to help us generate our image. In these examples, we're going to be passing in a prompt that contains just a small amount of context behind the scenes, such as, "You're a helpful assistant to a content author," along with additional context that the author can choose, such as the tone of the copy or the size and parameters of the output that we want, which in this case is images. And then we're going to pass in the user's prompt verbatim. Okay, so with that in mind, let's generate some content. So we're going to start with image generation. So what I'm going to do is go click on the ChatGPT logo here, and that opens up the AI assistant. And we're going to go into image generation mode here on the left. And then you can see some of the options that we have here about the image size and so on. That these go to augment the prompt. Now, create a hero image for my pizza delivery company called Ultimate Slice and use a modern, realistic aesthetic. All right, so now we're going to wait for that. I don't like that. I don't like those words. Try again. I would prefer a picture of pizza with no words. Okay, I like that. Let's take a look at it in full screen mode here. So we'll click download. All right, yeah, I like that. And now we're going to save it to the system. So I'm going to choose a folder. And then we'll set the name. Let's save that. And then let's place the image. So we're going to close the image and go to our asset picker and search for our file. There it is. And we just drag it and drop it where we want it. Now let's make some changes to the style here. Update the style in the hero section so that they are larger and white. All right, so let's change here. Now let's just fix this because we want the company name here. So we'll just make a small edit. And I think that looks great. We've used the chatbot here to help with some style changes, but then we make some standard edits. So we'll scroll down here, and the first thing we want to do is set this image. So let's search for another image. Okay, so I'll drop that in there. And then I need to change the copy underneath the image. Yeah, so let's go ahead and change that. So we'll open the chatbot again, which is in text mode, and give our prompt. Ultimate Pizza is the world's greatest pizza delivery company. We handcraft our pizzas with the finest ingredients and deliver them faster than any other company on earth. Write a short summary about our story. Okay, well, that's a little bit longer now. Let's turn on the audio so it can actually write back to us. This looks good, but make it even shorter and a little bit more exciting.
Here's an even shorter and more exciting version. Our story. At Ultimate Pizza, we live and breathe pizza. We're thrilled to craft the world's tastiest pizzas with the freshest ingredients and deliver them faster than anyone else on the planet. From a humble start to becoming the ultimate in pizza delivery, our passion for flavor and speed fuels every slice. Get ready to savor the excitement, one delicious pizza at a time.
Okay, that looks great. Let's copy this, put it in our clipboard, and we just select everything here and paste it, and we're done. Okay, that's pretty powerful stuff, right? But as Mike mentioned, we're going to want to be able to improve the quality of the responses we get from AI, both to make them more specific to our needs and also to reduce the risk of a low quality or incorrect response. We could train and fine-tune models to accomplish these goals. However, this can be time-consuming. And, as we've discussed, retrieval augmented generation, or RAG, and other similar prompt augmentation approaches are proving to be very effective as either an outright alternative to custom tuning and training, or can be used in combination with them to achieve better results by automatically and dynamically improving our prompts for us behind the scenes. So now, taking this into the content management space with CrafterCMS, let's first look at an example of a chatbot on the delivery side that can leverage all of the content on our example site in order to help answer users' questions. So starting with the architecture, we can see here in this diagram a crafter-based implementation of the previous diagram where we're using OpenSearch as the vector store and OpenAI as the LLM. And we're going to pass the prompt provided by the user through our orchestration layer. And this layer, using an out-of-the-box template called the Retrieval Augmentation Advisor, will automatically coordinate the entire sequence of events and processing of the prompt into embeddings and then help us retrieve similar documents from the vector store, which we then use to enhance the prompt and pass that enhanced prompt and context to the LLM to be processed. And once the LLM has generated a response, it can be returned or streamed to the end user as it's being generated. Note that the delivery side assumes that the vector store, in this case OpenSearch, is already populated with our content. But how does that get done? And when does that get done? Well, the embeddings for the content stored in the vector store get generated during the authoring and publishing activities, which first means that this happens out of band with the delivery, right? But it also indicates that our chatbot will stay up to date with every change that we make and approve from our authoring system. The way this works within Crafter is that our deployer plays a role in the orchestration layer with a RAG deployment processor. And this processor calculates what the user has changed and published with respect to the content, and then prepares that content as simple documents suitable to be processed into embeddings. The deployment processor then uses the LLM, in this case OpenAI in our example, to generate embeddings for the documents. And then the deployment processor takes those embeddings and updates the vector store with new and updated vectors, or removes vectors if they are related to content that has been deleted. So let's take a look at this in action, and a couple of points that you want to take note of. First, I'm going to run the demo inside of Crafter Studio's preview for our site. And it's important to understand that this invokes the deployment processor immediately whenever an author updates content within the preview environment. So our changes are going to become visible to us immediately, which is important in a preview environment. But on a live site, the deployment processor that we're using here will run when the content is approved and published, okay? So that means that our vector store is only updated after content is approved and published in the live environment. And the other thing that you'll notice here is that we're going to use the AI assistant to help us create the chatbot user interface first. So that's also part of the example, and we're going to learn more about that later. So with that in mind, let's jump into the demo. Add a new section under my hero image on my homepage template to allow users to interact with my company via a chatbot. The service the chatbot will call is /API/agent/chat.json.
Your content at path/templates/web/entry.ftl has been updated.
I like the new section, but can you make the chat area a little bit smaller and add copy on the left that describes how to interact with the agent?
Your content at path/templates/web/entry.ftl has been updated.
That's great. All right, now let's try it. So we can see we're kind of getting an error message here. So we'll edit the template, and I just want to show you what's going on here. So if we scroll down, we can see in the template that there's some code here, and essentially we've got generated code that's posting to the service that we requested. So we'll copy that, and it's a post. And now we're going to create a service. So what we'll do is right click here and create a new REST controller. Okay, so we give it a name and the method there, and now paste some code in here. And if we run that, we see we get a hello world. So now we've got a response. So it didn't generate the service. We had to generate that, but it generated the code. And then now what we're going to do is start to make this real. So instead of hello world, we can put some basic code in here. So the first thing our service has to do is has to get the request that was sent in. So I have a boilerplate sort of get request body here. You don't really need to understand what's happening there. We're just getting that. And then we're turning that to JSON. And we're just going to return that so that we can see that this post gets what we want and responds with it. So we're not talking to AI yet. So let's just open up the networking tab here, and we're just going through some mechanical stuff. Let's now put in a test here and send that, and you can see we get back hello world. And if we go in and look at our networking tab, you can see that we're also getting the input. So now we have a service that's really receiving what we're sending in. So we'll open the code editor one more time here. And now we're going to actually call the chatbot. So I'm going to put this input statement here at the top, which is part of that RAG chat framework that we have. And now I'm going to take this other code here that I've pasted in, and we're going to start putting it in the correct place. I'm going to paste this code in here, and you can see that the input message that we're sending into the result needs to be in the user prompt variable. So I'm just going to assign that. And then we go down here, and you can see that we're going to get the agent's response, and that's going to be as a result of the RAG chat processing the response. So just make sure that's a little bit more obvious there. And then the last thing that we want to do here is basically send our response and our user prompt back in our REST result, and then move there's a check here that we're going to move up before we process the result. So now we're going to ask a specific question. For example, what makes the ultimate slice the best? Now let's fire that off. Ultimate Slice stands out as the best due to its commitment to artisanal craftsmanship. What brand of cheese does Ultimate Pizza use? I'm sorry, but the provided information does not specify what brand of cheese Ultimate Pizza uses. Okay, now let's go down in our content. Let's add the answer to that question. We use Freshly Best brand cheese. Okay, now let's scroll back up and ask the same question. So we'll copy it and then paste it back in and send it back in. And now it responds, Ultimate Pizza uses Freshly Best brand cheese for their pizza. Now let's go make another change. We use a variety of old world Italian cheese vendors. And let's scroll back up and now ask the same question and see if we get a different response. At Ultimate Pizza, we use a variety of old world Italian cheese vendors to craft our delicious pizza. I love that demo. It's just awesome to see an LLM operating with all the information available on our sites and other supporting content, and that we can do this without having to train a custom model. Now, I want to talk about how we can take things a step further and start developing tools for our AI assistants and ultimately our AI agents. AI tools is an emerging term that refers to an LLM's ability to invoke functions, extensions, and APIs. And we're all familiar with APIs. So what I want to do is introduce the concept of function callbacks, which go beyond the ability to invoke REST or some other kind of API. Here we can see that if we send a prompt into the LLM that requests an action, say, for example, ordering a cheese pizza, even with RAG, the LLM is not going to know how to place that order. The best it will be able to do is suggest the steps to place the order manually, or maybe provide us with some code that we can use to execute and place the order in the context of an application. Well, that's helpful, but it would feel a lot more magical if this AI chatbot could work with us to place the order. And as we get into agents that are autonomous, we're going to see how this goes from something that is convenient to something that is necessary. Now, a great way to give the LLM the appropriate tools to do this is through what we call function callbacks, which are the ability to register and describe a capability in terms of what it does, what input it requires, and how it should respond to the LLM. And once we've described all of this, we can pass the function callback and its metadata into our prompt that we send to the LLM, as we can see here in step 1. The LLM will then determine if we're asking for it to take an action and if it has a tool that is appropriate to take the action or not. If it has such a tool, it will then confirm or acquire the information it needs in order to invoke the action, as we can see here in step 2. where the LLM calls back to the orchestration layer and invokes the function callback. The orchestration layer will then invoke an underlying API in one of our backend systems and acquire the result from that API and then forward it to the LLM, as we can see in step 3. And the LLM can then leverage that result to formulate a response for the user, as we see in step 4, and respond back to the user with that answer, as we can see in step 5. As you can imagine, supplying the LLM with these types of tools unlocks tremendous potential. Looking at this very same pattern in the context of Crafter CMS on the authoring side, we can see here that function callback based tools have been added to the Crafter Studio environment through the orchestration tier in order to perform tasks such as editing content, updating content models and templates, as well as taking actions such as publish or revert content and so on. And it's possible to do the exact same thing on the delivery side to extend and enhance the capabilities of our AI-powered end user experiences. Here we can see an example of a chatbot app that not only can answer our questions, but can help us check on and book or cancel reservations. So let's take a look at these two examples in action, starting with the delivery side. So let's start with a simple question: can I order pizza? So here you can see it's going to respond with yes, you can order pizza. You can go to the order now section and order the pizza. So it's going to give us advice. Now let's ask another question. Do you have meatballs in stock? All right, so a question that potentially we might be able to answer if we have the right capabilities, but in this case we haven't done anything yet, so it does say, I'm sorry, I can't confirm if there are meatballs in stock. So what we're going to do is we're going to go back to our class where we are running the RAG chat. We're going to edit that service to give it some new capabilities. And you can see here that we're going to start introducing this idea of a function and a function callback wrapper. So this is our function. It's going to be the check availability tool. Okay. And all it does is it takes an ingredient and it returns a true or false if that ingredient is available. And then I've hard-coded it to return true. Okay. Now what we're going to do is go up to where we are running our RAG chat, and we're going to introduce this code here where we take our function and create a function wrapper, and then we describe how that function works and build that function call wrapper. And then when we execute the prompt, we're going to add that function here. As you can see, I've highlighted that. Okay. And that gets added to the RAG chat advisor. So in addition to doing RAG, it can do the function calls. So now let's ask if there are meatballs in stock. And it says, yes, we have meatballs in stock. Okay, cool. Let's see if we can order a cheese pizza. It says, I can confirm that cheese is available for your pizza order. However, I cannot place the order directly for you. So again, now it's starting to be able to do some more interesting things. All right, now, just to show that this function is working, let's change the response to false. And let's ask if we can order a cheese pizza. All right, so it says, I'm sorry, but it seems that cheese is not available now. Okay, now let's look at the same sort of example on the authoring side, and we're just going to use functions that are built into the assistant.
Describe the world's greatest pizza delivery company.
Creating a description for the world's greatest pizza delivery company involves highlighting unique strengths, cutting-edge technology, commitment to quality, and exceptional customer service.
That's awesome. My company, Ultimate Slice, fits this description exactly.
That's fantastic to hear. Ultimate Slice sounds like an incredible pizza delivery company that embodies excellence and innovation in the pizza industry. If you need any assistance with creating content or presentations that reflect this vision in CrafterCMS, feel free to let me know. Your description could certainly attract and delight pizza lovers everywhere.
Update my homepage with a modern, responsive design that promotes my company.
Your content at path/templates/web/entry.ftl has been updated.
Let's take a look at this. This design is nice, but I would like to change the sections so that the images are offset left to right and we include more copy that describes the business.
Your content at path/templates/web/entry.ftl has been updated.
All right, let's take a look. Now you can see we do have some parallax images in the background. We do have some offset text. Add a sticky navigation bar at the top with common pizza delivery company features and sections.
Your content at path/templates/web/entry.ftl has been updated.
All right, let's take a look. Yeah, it sticks. That's great. All right, now we need to update our content model. Analyze my template to find all of the placeholders for the content model and their types.
Let's analyze the placeholders in the free marker template and determine their types based on the field suffixes.
Thank you for the list of placeholders. Please update my form definition with new fields for all of these placeholders.
Your content type page entry has been updated.
And if we open the form here, we can see all of our fields. So the assistant was able to help us build the entire page and make it editable. Now we've seen how these tools work in the context of a AI assistant and just how powerful that is. Let's take another step forward and think about how that applies to agents. Remember, as Mike pointed out, agents are AI apps that are able to act autonomously to fulfill a goal that may be complex and that may require multiple steps that need to be planned and executed. With this in mind, it becomes obvious that tools like function callbacks are necessary in order for agents to have agency. But in addition to these types of tools, agents, unlike an AI assistant, are going to need some additional context. Our orchestration layer, along with the LLMs and other services and stores in the layer below, need to provide support for long-lived AI-powered background processes that define the lifespan of an agent and its tasks. It's in this context that AI agents can act autonomously on behalf of our users, guided by their instructions in the form of objectives, task parameters, and guardrails that define the desired outcome and scope of the tasks. And in the diagram, we can see exactly where AI agents are implemented in terms of our tiers and how powerful it is to be able to give an autonomous agent the ability to carry out complex tasks for us, such as moderating comments, maybe writing and scheduling content, or, for example, identifying and updating outdated content on the authoring side. And we can imagine similar examples on the delivery side to help facilitate and guide an end user through a complex workflow or other aspect of their customer journey. So with that in mind, I hope you're as excited as I am having looked at some of these capabilities in action. And what I'd like to do now is turn things back over to Mike so that we can take some questions from the audience.